Hello, welcome again. We are solving some questions of thermal engineering. The topic is IC engine, compressor, and gas turbine. Question number 12 is the crank radius of a single cylinder IC engine is 60 mm and diameter of the cylinder is 80 mm. The swept volume of the cylinder in centimeter cube is, so the crank radius is 60 mm. So length of stroke will be double of crank. Okay, so crank radius, that will be 60 into 2. Okay, so it will be 120 mm. So diameter of cylinder is 80 mm and swept volume is pi by 4 d square L, and d is your d is diameter of cylinder, that is 80, and L is length of stroke. So so length of stroke is 120 mm. So when the piston is at top dead center, the move from top dead center to bottom dead center, so it travels a distance of 2r, that is equal to n. So length of stroke is here 120 mm. So shaft volume is pi by 4 80 square into 120, or it will be here 603.185 centimeter. Okay, in cc. Option B is the right answer. Question number 13 and 14. In two air standard cycles, one operating on the Otto and other on the Brayton cycle, air is isentropically compressed from 300 to 450 Kelvin. Heat is added to raise the temperature to 600 Kelvin in the Otto cycle and 500 Kelvin in the Brayton cycle. If xi naught and xi b are the efficiencies of Otto and Brayton cycle, then option A, efficiency of Otto cycle 0.25, Brayton cycle 0.8. Option B, both cycle have same efficiency, that is 0.33. Option C, efficiency of Otto cycle is 0.5 and efficiency of Brayton cycle is 0.45. And option D, it is not possible to calculate the efficiencies unless the temperature after the expansion is given. Okay. Question number 14 is, if W0 and WB are work output per unit mass, then W0 greater than WB. Option A, W0 is greater than WB. Option B, W0 is less than WB. W0 is equal to WB. Option D, it is not possible to calculate the work output unless the temperature after the expansion is given. So as the temperatures of the Otto cycle are given at minimum temperature is given as 300, and that temperature after compression is given as 450, and temperature after heat addition is given as 600 for Otto cycle. Okay, so on Otto cycle, okay, temperature before compression is 300 and after compression is 450, and this is your 600. Okay, and in for sorry 600 for Otto cycle and 500 for Brayton cycle. Okay, so the temperature T1, T2 and T3. T1 is before compression, this is after compression, and this is your after heat addition 600. Okay, so from T1, T2, because T2, T1 is your isentropic process, isentropic compression in Otto cycle. So we can find out the compression ratio. So T2 by T1 is equal to R gamma minus 1. This is called gamma minus 1, where R is compression ratio. Okay, so now we have T2 and we have T1. So we can find out R, or because we don't know R, we need R gamma minus 1. So R gamma minus 1 is T2 by T1. So efficiency will be 0.33. Okay, so efficiency of Otto cycle is 0.33. And in case of Brayton cycle, T1 is your 300 and T2 is your 450, and but T3 is changed, that is 550. Okay, so this is your this is T2 by T1 will be your T2 by T1, and gamma minus 1 by gamma. And so for T2 is 450 and T1 is 300. So we can find out RP gamma minus 1 gamma by gamma is 450 by 300. Okay. So RP is your pressure ratio. So Brayton cycle efficiency is given as 1 by 1 minus 1 by RP gamma minus 1 gamma minus 1 by gamma. Here the RP is pressure ratio in Otto cycle. R is your compression ratio, that is the total volume by clearance volume, and that is the ratio of pressure. Okay, P2 by PL. Okay, and so this value is your 450 by 300 or 450 by 300, so it is 0.33. So Brayton cycle is 0.33. Efficiency Brayton cycle is also 0.33. So efficiency Otto and Brayton cycle are 0.33. Okay, so now heat supplied. Now heat supplied in Otto cycle is CV during constant volume process, CV T3 minus T2. Okay, and this is your 0.7. T3 is known, T2 is known, that is 600 and 450. Okay, and efficiency of Otto cycle is 0.33, that we have calculated. So work done will be efficiency into heat supplied. So that will be 35.541. And in the Brayton cycle, the heat is supplied at constant pressure, and T3 is known, T2 is known. So heat supplied is 100.5, and efficiency Brayton cycle is also 0.33. So work done will be your efficiency Brayton cycle into this heat supplied, that is 33.165 kJ. So work done in Otto cycle is less than work done in Otto cycle is less than Otto cycle is sorry, 35 is more than the work done in Brayton cycle. So answer is option A. Okay, and here the answer is option B.